Good evening to all of you. Myself, Pooja Jindal, in Marine and Atmospheric Sciences group of IIRS. So, today's my topic is satellite-based fog estimation and analysis. Let's start with the definition of the fog. Fog is defined as the water droplets suspended in the air which reduce the visibility. That is, when you look in the horizontal direction, actually you are not able to look so far because of the suspended water droplets. And as per the accepted definition, when the visibility is less than 1 kilometer, then that condition is called as a fog. As fog is similar to the clouds, that is, its appearance is very similar to the clouds, so fog is also defined as clouds sitting on the ground. Now, why is it important to study the fog? Because fog is a very critical weather situation, because first of all it obstructs the air, land and sea traffic. We all aware that how much aviation is affected and how much the road traffic is affected, and sometimes there are the many accidents over the Indo-Gangetic plains because of the very low visibilities during the winter months of December and January every year. And also it delay the thermal dissipation of the temperature inversion. So let's understand what is the meaning of temperature inversion over here. So we all know that in general, as we move high in the atmosphere, temperature reduces because of the lapse rate. But during the winter times, what happens is during the night time, because of the lot of the thermal emissions from the surface, the surface temperature reduces a lot. Why? Because during the winter times, the night is very long, as well as winter nights are usually clear. Clear means the clouds are very less, due to which the thermal emissions are there and the surface temperature reduces to a larger extent during the winter times. So what happens is, near the surface actually the temperature reduces because of the conduction with the earth's surface. So what happens is, during the winter times, in the night time, as we move high in the atmosphere, for some altitude, temperature first increases and then decreases, so making a kind of the inversion, temperature inversion at an altitude of around 1 to 2 kilometer. So this kind of the phenomena is called as a temperature inversion. So what happens is, whatever air is below this inversion layer, that is a very stable layer, right? Now because it is a stable layer, so it traps the air pollutants. Now because it traps the air pollutant, so of course it delays the thermal dissipation, because whatever radiations are coming from the top, that is the sun's radiation, it will be reflected back, so therefore it delay the thermal dissipation. Also, you know that any long term change in the fog or in any other climatic variable can also affect significantly the radiation balance of the earth, which may leads to the climate change. Now, what are the observations available of the fog? One way is of course the ground observations. So there are the two ways of the ground observation. One is the manual and one is the automatic. In the manual observations, actually a person at the various locations sees how far he or she can see, and then it noted down, and such kind of the observations are repeated every 3 hours or so. And in the automatic observations, instrument called transmissometer is used, which keeps on noting the reading every second it keeps on noting down the reading, right? So like on all the airports we have the automatic observations of the visibility, right? But in the ground case, whatever number of the observation you have, it will be always be limited in the numbers, right? You may not have the full spatial coverage, it's not possible. And also the observations are reduced during the night time, especially the manual observations. And also if you want to have the observations over the ocean or the remote areas, that are also very limited from the ground instrumentations. Now because of all those limitations, we come to the satellite fog maps, because the satellite, it have the very high spatial as well as the temporal coverage. Therefore whatever information we get from the satellite is very important, and therefore the fog estimation from the satellite is an important topic. Now let's see what are the major factors which influence the fog formation. So first is the relative humidity, which is defined as the ratio of the water vapor which is there actually in the air compared to the maximum amount of the water vapor for the saturation to occur at that particular temperature. It means that maximum amount of water vapor means if you add any additional water vapor into that air parcel, it will saturate, right? Means it will then condensation will take place. That is, the fog formation will start, right? So at the saturation, relative humidity will be 100%, means the air actually contains the maximum amount of the water vapor it can hold. Then comes to saturated air. So as already discussed, it contains the maximum amount of the water vapor that is possible at the given temperature and pressure. Then the condensation nuclei. So condensation nuclei are the surfaces of the that aerosols or smoke particles on which the water vapor condense. See, in ideal situation, when there is no condensation nuclei, the condensation will start only when the air is saturated, that is when the relative humidity is 100%. But in case if there are the condensation nuclei, then the condensation even start if the relative humidity is around 70 to 80%. Why? Because some sort of nuclei are there which actually facilitate the condensation, right? Then coming to the last is the dew point temperature. So it is the temperature to which the air should be cooled with no change in the air pressure or moisture for saturation to occur. So in ideal cases, when condensation nuclei are not there, at the point of the fog formation, the air parcel is 100% relative humidity and it is saturated, as well as it is at the dew point temperature. So if condensation nuclei are there, then even at the lower relative humidity, fog formation may start. Now let's see a few other parameters which are similar to the fog, that is dew, frost and haze. Let's see slightly the difference between these four things so that we can understand how the fog is different from the haze, frost and dew. So let's start from the dew. Dew, a very small water droplets that we usually see in the early morning hours on the vegetation. Right. So how does it forms? So again, during the winter nights, it's a very clear nights and the long nights, lot of the emission occurs, the surface get cooled, right? So what happens is the air which is very close to the surface, when it touches the surface features, the condensation take place, right? And the dew formation take place, right? And it usually form on the vegetation, not on any other surface like road or building, because vegetation has the lower heat capacity, that is vegetation cooling is fast as compared to the building or any other feature. Then frost. Frost forms when the dew point is below 0 degrees Celsius, right? In this case, the water vapor changes directly to ice without becoming a liquid. So this usually occurs in the high latitude areas. Then coming to the haze. Haze is also, accumulation of the dust, aerosols and smoke particles which restrict the visibility, right? So when there is no water vapor content, then we call it as the dry haze. But if the water vapor deposition is also there, then we call it as a wet haze. The major difference between the wet haze and the fog is in concern with the visibility. So if visibility is say less than 1 kilometer, then it is called as a fog, and if it is more than 1 kilometer or 2, 3, 4, 5 kilometer, then we call it as a wet haze. Okay, then finally coming to the fog. So fog, we have already discussed how does it forms. During the winter nights, there is a lot of the thermal emissions, so relative humidity increases, right? So when relative humidity reaches around 75%, the water vapor start condensing into the condensation nuclei and start scattering the visible light, and a kind of the haze start forming. That is, we are not able to see fully in our horizontal direction. Our visibility actually reduces because of the scattering of the visible light due to the suspended water droplets which has been condenses on the condensation nuclei. However, relative humidity starts keep on increasing because there is during the long nights, there is a lot of thermal emissions are there. So temperature reduction is still going on. So relative humidity keep on increasing. So as the relative humidity increasing, these particles grow in sizes as well as in number. Therefore, our visibility further reduces. So when the visibility reaches less than 1 kilometer, so we call it as a fog or the cloud resting on the ground. So what are the conditions necessary for the fog formation? There are the four major conditions necessary for the fog formation. Of course, relative humidity should be very high. Surface should be cooled. Temperature inversion should be there. We have already discussed. And wind should also be light. Means that the low wind should be there. You know why? Because if winds are high, then the air which has been cooled due to its connection with the cold surface, it will move, it will change its place. So if it will change its place, then it may go to some other surface which is not so cool, so that then it may not lead to the formation of the fog. Therefore, wind should be very light. So usually the winds in the range of around 2 to 3 meters per second has been reported for the fog formation. If it is more than 2 to 3 meters per second, then the fog formation is very rare. Now coming to the classification of the fog. Fog can be classified into various types depending on the processes of the formation, depending on the visibility, and depending on the appearance. So depending on the processes of the formation, we have radiation fog, advection fog, mixing fog, steam and frontal fog. And depending on the visibility, we have dense, moderate and thin fog. And depending on the appearance, we have smoke, smaze and frost smoke. So we'll briefly see each of these types. So starting with the radiation fog. Radiation fog is the same that we have just discussed. That is, during the winter nights, there is the heat radiation from the Earth's surface which cools the lower layer of the atmosphere, and if the cooling is sufficient that the air reaches the dew point temperature, so it means the air has become saturated, relative humidity is high, so the water vapor start condensing and hence the fog formation starts. Right, so this is radiation fog is one of the major type of the fog that we witness in India over the Indo-Gangetic plain. That is the major type of the fog. Then coming to the advection fog. So as the name suggests, advection is related with the horizontal motion. So in this type of the fog, what will happen is warm moist air will move over a cold surface. So when warm moist air from some other place will move over the cold surface, what will happen? That air will start cooling down because of the contact with the cold surface, right? Now because of the cooling, its RH will start increasing, right? And the dew point, if it reaches the dew point, that is if RH has become very high, then condensation may take place, that is leading to the formation of the fog. So the fog formed in this process is called as an advection fog. So advection is another kind of the fog that we see over the Indo-Gangetic plain. So these are the two kinds of the fog, that is radiation fog and advection fog, that is mostly we see over the Indo-Gangetic plain. The subgroups of the advection fog is the sea fog, tropical air fog and upslope fog. Sea fog, as the name suggests, the fog formation over the sea, that is when the air move from the from some other part of the sea to the colder part of the sea. The fog formation is called as a sea fog. Tropical air fog, so when the air moves from the lower latitude to the higher latitude region. So you know that as we move from the low latitude to higher latitude region, temperature reduces. So if the reduction is sufficient that the air can cool down to the dew point temperature, fog formation may take place. Then the upslope fog, again as the name suggests, when the moist air moves along the elevated plain, hill or mountain. So you know that as the air rises, it expands. Due to expansion, it cools down, and if the cooling is sufficient that it may lead to the dew point temperature, then the fog formation may take place. Then coming to another type, that is a mixing fog. Mixing fog occurs when the warm moist air come in contact with the cool moist air. So warm moist air when come with the in contact with the cool air, so again the cooling may be sufficient that the dew point temperature may be reached. So one example of the mixing fog is that we see in India during the winter time, especially in the North India, when we breathe, when we breathe, just outside our mouth for some area we see the some fogginess. So what is happening is, warm moist air is coming out from our mouth or the lungs, right? And then it is mixing with the cold air outside, right? Because it is a winter time. So due to that mixing, this air's temperature is going very down and reaching the dew point temperature. Therefore the fog is forming, but it soon dissipates because the outside, it's a very large area, right? So it further mixes with the dry air and then it dissipates. Right. And then the steam fog. So steam fog is produced by the intense evaporation of the water into the relatively cold air. So when you say evaporation of the water, so this kind of the fog usually occurs, over the river or any other water body, sometimes over the swimming pools also. Then comes last is the frontal fog. Frontal fog is found along the boundary of the two air masses. So this is also a type of the fog which is not there in our region. It is also there in the high latitude region only, because we don't have the air masses concept over the tropical region. Then depending on the visibility, the fog is the dense fog when the visibility is very less, and it is the thick fog when the visibility is around 200 to 400 meter, moderate fog around 900 meter, and it is a thin fog sometimes we call when the visibility is around 1.8 kilometer. And after that, of course, we call it as a haze. Then depending on the appearance, we have smoke. Smoke is basically smoke plus fog. We have smaze. Smaze is nothing but smoke plus haze, and frost smoke. Frost smoke usually is only in the Arctic region. So we'll not go into detail of this. Now coming to the main part, that is the fog detection using the satellite data, right? So we have already understood why we want to get the fog from the satellite, because of the limited number of the observation from the ground observations, but from the satellite we get the synoptic view, that is the very large spatial coverage. So these are basically the MODIS images, true color composite of the MODIS images, right? So if you see this first image, let's try to see where the fog is. So this is the Indian region, right? So here you can easily see this is a mountain region, right? And this white patches are of course the snow. You can see from the texture, it's very clear that this is the snow over the mountain region, okay? So these white patches are the clouds. This is the cloud. This is also white patch. This is also kind of cloud only, but if you see here, this cloud patch is different from this. It's different from this also. It is different than this. What is the difference? This patch is very smooth. One thing is this, and then if you see, its boundaries are also very sharp, or you can say edges are very sharp on all the sides. So these are the basic characteristics of the fog. See, it is also kind of the cloud only, but how we will distinguish the fog from the other kind of the clouds? Fog have the smooth top and it has the sharp edges. So this is all the all patch, the very big full patch of the fog over the Indo-Gangetic plain. So this image is for December 17, 2019. So if you see December 16, so this is the part of the fog here, covering the full Punjab, Haryana and western UP, some part of the Rajasthan also. Then December 23, 2018, if you see only a very small patch of the fog. So rest all, like here we have the clouds, here we have the snow, these are the clouds. These are also of course clouds, and these small, if you see this small very light, you can say this part is basically indicating the haze. See, this is of course, like here you see the clear land, here you're not able to see the land clearly. This is because of the haziness. So now we understand visually how we can see the fog and how we can discriminate it from the other type of the fog, from snow and haze, and of course the land features. But if we come to the mathematical retrieval, like if I give this image, any image, and I want that I should get only the fog image, right? For example, like this. So this is the image of 16 December 2019 at 12 UTC. On this day, only this was the patch of the fog, but this is the original image. So I want to get this kind of the map from this image, right? So this process is basically called as a retrieval. That is, I want to retrieve the fog from the satellite image. Okay, let's see this image. This is the infrared channel. So infrared channel is basically based on the temperature. Okay, so this is the all white part. Low temperature means it is the indication of the clouds, of course. And I'm not sure if you can see here, very slight land ocean boundary is there. So this is basically Indian region, right? And this is the whole mountain region. Himalayas are there. So this is very clearly snow is there. These are also cloud. Now if you see, try to see here a very small gray patch which has a very slight difference in the shade with the land. So this is basically fog patch. So why this slight variation? Because fog is near the surface. So fog top temperature is very similar to the land surface temperature in thermal channel. Thermal channel is 10.5 to 12.5 micrometer. So in this channel, your temperature difference of the fog top and the surface is very less. Therefore, we are not able to visually see the fog very clearly. But there are various mathematical techniques that we can apply and we can get the fog image. So we'll discuss how to do the retrieval. So I'll discuss with you the methodology for the fog retrieval. First of all, I would like to tell you that for the fog retrieval, there are the two separate methodologies. One for the daytime and one for the night time. We cannot have the single methodology for both the times because of the difference in the availability of the channels. During the daytime, visible channel is available, but the visible channel is not available during the night time. In the visible channel, we can see the bright foggy patch, but as the visible channel is not available during the night time, we cannot use that channel or the same methodology for the night time. So let's discuss one by one. So for the daytime, what are the major steps involved in the fog retrieval is, first of all, we try to remove the middle and high level clouds. So how we will do that? We can do using the thermal channel. So as I already told you, in the thermal channel, it is a temperature which has been indicated. So high and mid level clouds are going to have the lower temperature than the fog top because fog is near the surface. So I can put a threshold and remove the high and mid level clouds. So I'll simply say that the pixels with the temperature less than this particular values are masked. That is, these are the high and mid level clouds. Then I want to remove the snow pixels also because snow is also white and the fog top is also white. So this is being done by using the visible channel. How? Because in the visible channel, reflectance of the snow is large as compared to the fog. So the pixels with the reflectance more than a particular threshold values are masked. Similarly, the bright land pixels are also having the very high reflectance and they are also being masked. One example of the bright land pixels is the desert. So if you see the visible images, in the visible images, bright land pixels or the desert areas also have the very high reflectance. So both snow and the bright land pixels shall be removed using the visible channel. So once the snow, bright land pixel, high and mid level clouds are removed, so I am left with mainly with the fog and the other land features, which may include vegetation, buildings, land, everything. But it except the fog, all other atmospheric features or other bright features have been removed. Now how I will can remove the land? If I have some clear sky image. Clear sky image means when there is no fog, no cloud in the atmosphere. If I have that kind of the image and if I subtract that image from this image, then I can get the foggy image, right? So how can I get a clear sky image? So clear sky image I will be generating. How I will generate? I will take the 15 days of the data. For example, I am doing all this process at a particular time, say 4 UTC, right? That is around 9:30 in the morning. Then what I'll do is I'll take the same time image for the last 15 days. Means I'll take the visible data of 9:30 UTC for the last 15 days. Say I'm working for the 15th December, then I will take the data from 30th November to 14 December. So what I will do is, for each pixel, I will check for each pixel and take the minima of the last 15 days. Right? So if I take the minimum of the last 15 days, and I'll assume that in last 15 days at least there will be one day when it is the fully clear sky, that is no fog, no cloud is there, and I am taking the minimum. So whatever image I will generate, that will be the clear sky image, right? So then I will take the difference of these two images and I will get the fog image. Of course, there are the further more processing for the further fine tuning of the fog, but we need not to go into detail of that. So these are the few major steps involved for the fog formation. First is the removal of the high and mid level cloud using the thermal channel, then removal of the snow and bright land pixel using the visible channel threshold, and finally the removal of the land pixel using the clear sky images. And another thing is, whatever we will get in our result, that will not be fog only, it will be the fog and low stratus cloud images. Why? Because low stratus clouds are also forming very close to the surface, not at that surface. Difference between the fog and the low stratus clouds is, fog is at the ground and low stratus clouds are not at the ground, it is little elevation, but of course it is not very high in the atmosphere. But both of these things, fog as well as low stratus, looks very similar from the top. Therefore our simple methodologies are not able to distinguish between the two. So whatever we will get as the output, that is the fog and the low stratus images. So this is one example where we have retrieved the fogs for 11th January 2021 at 5 UTC. You can see the spread of the fog over the full northern UP, Bihar, Punjab, Haryana and some part of Pakistan also. And we have compared it with the RGB composite. So in this composite, this green color is showing the foggy area. So you can see that the methodology is very good to retrieve the fog. And then as we have done it using the INSET 3D data, which is a geostationary data, and it's available after every half an hour. So every half an hour you can retrieve, and we can also do the temporal monitoring of the fog. So that is a fog monitoring. And then you can understand at what time fog formation has started, how it is increasing, and when it start dissipating, and all the things, all the spatial distribution at the several times of the day can be seen, because the data is available after every half an hour. Then coming to the nighttime methodology. So as already said, the similar methodology for the daytime cannot be used for the nighttime because of the absence of the visible channel, right? And also, I told you the thermal contrast between the fog and the surrounding clear area is very less in the thermal channel. So that is also one shortcome. So what we do in the night time? So night time we use the mid IR channel. Mid IR channel is at 3.9 micrometer, right? So what is the peculiar of the fog in mid IR channel? So actually the fog has very low emissivity in mid IR channel. So if it has a low emissivity in mid IR channel as compared to the thermal channel, so if I take the difference between the two, I will get the positive difference. However, for the other features, that kind of the thing doesn't hold. That is mid IR. In mid IR channel, other features doesn't have the low emissivity, right? Like for example, you see these two images, right? So one is the thermal image and one is the mid IR image, and I draw a transect over the foggy area. This is the foggy area, which is a smooth part. So when I plot the BT in the two channels, so this is the area which shows the foggy part. So if you see, the difference between the two is positive. This is the thermal channel, this is the mid IR channel, and it is around 7 to 8 Kelvin, right? So when we take the several images and try to plot this kind of the graphs, we understand that usually or mostly the difference is at least more than 2 Kelvin, right? In this case, difference is more because the fog is very thick fog, but usually the difference is more than 2 Kelvin. However, if you talk about the other features like the land feature, then this difference will be much less than 2 Kelvin. Also the snow and your cloud also removed in this method. For example, if you see the cirrus cloud, these are the here In case of the cirrus cloud, the difference is actually negative, right? So clouds will also be removed easily. So if you see, the methodology during the night time is more straightforward. It has only one major step, that is the difference of the thermal channel and mid-IR channel, and we'll say whenever this difference is more than 2 Kelvin, that is the foggy area. Okay, so one thing is the same methodology cannot be used during the daytime. You can ask mid-IR channel is available during the daytime also, but we cannot use the same methodology during the daytime. Why? Because mid-IR channel, which is at 3.9 micrometer, it also have the solar contribution. So during the daytime, what will happen is the solar contribution as well as the thermal emission from the surface will mixed up, making the values very high in the mid-IR channel. Therefore, this method cannot be used during the daytime. However, during the night time, solar contribution is cut. Only the thermal emissions from the earth is there. Therefore, this kind of the methodology can be applied during the night time. Okay, so this is one example. Here I have shown you IR image as well as mid-IR image. So subtracting these two images, we are getting the fog map. Okay, so subtracting as well as putting a threshold of 2 Kelvin. So wherever BTD greater than the threshold, those pixels are kept, rest are masked. Okay, and this threshold is usually around 2 Kelvin. Right, so this method has also worked to distinguish between the fog and the snow, right? Because emissions from the snow is also very high. If the emissions are high in the mid-IR channel, we won't get the positive difference, so that is removed. And this method is very versatile to the type of the terrain and the surface temperature over which it detects the fog. It means that fog is whether formed over vegetation or any other land feature, or the temperature of the surface may vary, but this method is able to detect. Some of the flaws in the method, let's discuss that. If the surface temperature is much less than 0 degrees Celsius, then of course there is increase in the instrument noise. However, if the temperature is not going below minus 20 degrees Celsius, fog signal is strong enough to be observed. Also, sometimes certain type of the soil produces the similar difference in the BT, brightness temperature, as the fog and result in the false reading, right? But this can also be countered by the repeated observations, because in the repeated observations fog may change but the soil position will be same. So in every repeated observation, if these things are same, so we can say that the difference is not due to fog, this is actually due to the soil. And also sometimes higher base stratiform clouds such as the stratocumulus and altocumulus often gives the positive brightness temperature difference values and resembles the fog. But again, there is a way to counter this. This is with the interrogation of the texture. We know that the fog top is smooth, but the top of these clouds is not smooth. Second thing is the brightness temperature. Brightness temperature of these clouds will be very less. However, the brightness temperature of the fog will be high because fog is near the ground and these are the higher based clouds. Okay, so brightness temperature method used in the nighttime detection cannot be used during the daytime. We have already seen because of the solar contamination. And mid-IR images, however, can be used for distinguish the fog from the snow during the daytime. Why? Because reflectance from the snow is much less than the fog in the mid-IR channel. In mid-IR channel, fog will be very bright and the snow will be dark. So these are the few of the images retrieved in the night time. The first set is from the InSat 3D and the second is from the InSat 3D R. So I'm showing the two because if you see InSat 3D and 3D R, time is adjusted in such a way that if you take both the data sets, you will get the temporal resolution of 15 minutes. So if the InSat 3D is at 14 UTC, InSat 3D R is at 1415 UTC, then InSat 3D will be at 1430, then 1445. So we may have the very high temporal resolution, which is very much required for the fog related studies. Then again another retrieval on 10th January 2021. So here we have shown the comparison with the RGB composite. right? So you can see the matching of the retrieved fog and the normal RGB composite. Again, the retrieval at the various times, so you can see how temporal variation of the fog is there. Like here, if you see at 17 UTC, it has just start forming, and then its spatial extent is increasing, and then it is almost same up to around 2030 UTC and 2230 UTC, and then it start dissipating. Then these are the another set of the images for 10 to 11 January 2022. That is a recent images. So here again, if you see from the 20 UTC to next day 12:30 UTC, images are there. So you can see how the temporal variation in the fog is there. And we have also shown the comparison of the one of the image with the RGB composite, which shows the strength of the algorithm which is being applied for the retrieval of the fog. If you see, this is a nighttime method, it was only one step method, and if you see the comparison, this is very well matching, and hence you can understand the strength of the methodology. Then how we can distinguish between the fog and low level stratus cloud. So till now I told you whatever we are getting from the satellite, that is basically the mixture of the fog and low level stratus cloud. We can do it using some visual characteristics, right? Like, flat texture, sharp edges, and the patterns that conform to topographical features like river bed or mountain valley. So these are the characteristics of the fog. Low level stratus clouds won't follow this kind of the pattern. Like I go back and show you here in the image here. So I show you, see, this is following a this is the foothill. This is a foothill, so it is following this pattern. So this kind of the pattern, or you can say characteristic, is true for the fog only, not for the low level stratus cloud. So this kind of the visual texture or visual characteristics can be used to distinguish between the two. And also sometimes we can also use the temperature difference, because the low level clouds will be at some higher altitude than the fog, although the difference will be less, but it will be at the slightly higher altitude. Therefore the temperature of the cloud top will be little lower than the temperature of the fog top. So that kind of the characteristics we can use to have the rough distinction between the fog and the low level stratus clouds. Then coming to the some of the detection problems. So we are calling it as a common because these are the true for both day as well as the night time algorithm. Like one of the problem is if there are some clouds above the fog, right? So because we are using the thermal channel, visible channel, which are not able to penetrate the cloud, so if there is any cloud above the fog, we cannot detect the fog, right? And some other issues are the sometimes the small areas of the fog. We are using the InSat 3D, which has the horizontal resolution of 4 kilometer, and if there is a smaller patch of the fog, say 1 or 2 kilometer area of the fog, that area of the fog would not be able to detect it by the InSat 3D. Then if there is a thin layer of the fog, if the layer of the fog is very thin, then reflectance will be less, right? So reflectance will be less, right? As well as the thermal difference will be very less, so we won't be able to see that kind of the fog. And also sometimes a shorter duration of the fog may go undetected, but these days geostationary satellites are there which have the very high temporal resolution. So as far as geostationary satellite data is concerned, usually we are able to detect the fog, but if you use the polar satellites, then of course you won't be able to get the shorter duration of the fog. Then some of the fog episodes over Dehradun. Actually, Dehradun is an area where usually we don't have the fog occurrence, but in last few years, 5 to 6 years, we are witnessing the fog over Dehradun. So we try to see whether our algorithm is tried to catch that kind of the fog or not. So these are the two fog images for 16 and 17 December 2019. So this red point is basically indicating the location of Dehradun. So on these 2 days, we actually witnesses the fog, and algorithm has also catch the indicating the presence of the fog over Dehradun. and we further confirmed it using the ground data. So this is basically the ceilometer data. Let me tell you what it gives. Ceilometer is basically ground based instrument. It's a laser instrument. It sends the laser signal in the upward direction and then receive the back scattered signal up to 7.5 kilometer altitude from several points, right? So in case of if it encounter any cloud in between, then the back scattering will be very high, right? So in this graph, this is y-axis is altitude and x-axis is time. So if I will have very high back scattering at the surface or near the surface, then I will say that okay, there is a cloud at the surface, and we know that the fog is nothing but cloud sitting on the ground. And if you see here, we are getting these white patches. The white patches means here we have very high back scattering, right? So if you see, it is the time starting from around this is around, you can say this is in hours, so this is around 7 p.m. This is starting from around 7 p.m. Very high back scattering is there, and we also witnesses the same. So actually the fog was there, so it persisted on 17th also, right, till morning around 9 a.m. there was a fog, and then during the daytime fog was not there, and again on the 17th the evening it started and it persisted till the 18th morning, right? So we confirmed using the ground truth data also, fog was actually there in Dehradun on 16-17 December 2019. Then this is the dates on the 2021 when we witnesses the fog over Dehradun from on January 10th and 11th. So here you again the red dot indicates the location of Dehradun, and here I have shown with the plot of the visibility from the synoptic observations. Previous this was from the ceilometer, this is from the synoptic observation, that is simply visibility. So you can easily see that the visibility, you know, wherever it is less than 1000 meter, we say it as a foggy area. So at on 10th January from 15 UTC to 11th January 3 UTC, the visibility was very less, right? It is much less than 1000 meters, so it indicates the presence of the fog. The same indication is from the satellite data also. Thank you. This is all from my side. Now if you have any